Hello, welcome to Zigmatech Learning Hub. I will be your instructor for further mathematics. For this class, we are going to be taking our exercises from the ExamGuide app. If you don't have the application already installed on your device, I will want you to download the app in order to follow along in this class. ExamGuide is a leading educational app that helps students prepare adequately for various exams like UTME, post-UTME, WEAC, GCE, KCPE, IJMB, JUPEB, KCPE, BESE, JSCE, NCEE, NECO, etc. You can download the app from www.examguide.com or Google Play Store. Please subscribe to our channel and turn on the notification bell to be updated on new videos. Ready for today's class? Okay, let's get started. Welcome once again to today's class. We are going to consider differentiation once again. As you know, let us see the specific objective we are going to follow. First one is using first principle to solve a problem in differentiation. Secondly, we are going to apply the knowledge of differentiation in solving problem or in problem solving. The first principle, we already know that in first principle, if y is a function, that is f of x, that the y plus y equals f of x changing s. General formula. Now let us take a question. Find from first principle the derivative of what? Y equals ax. That is, this is a function. Y is a function of ax. So changing y plus y equals a here is the f we are seeing. A into x plus changing x. So that's changing y plus y. What is our y here now? Is ax equals ax plus a changing x. Making changing y subject of the formula, we have ax plus a changing s minus ax. This will take care of this. Changing y is going to give us a changing s. Dividing through by changing s, we'll have that the y all over the s equals a. So that's the solution to that question. The next question, find from first principle the derivative of y equals 3s cubed plus 2s squared plus 5x The best way of solving this, you separate, take them one after the other. This is 3s cubed. Changing y plus y equals 3 into x plus changing s all cubed. And changing y plus y equals 3 into s plus changing s all squared s plus changing s. dy plus y equals 3 into s squared plus 2s changing s plus changing s all squared into x changing x. Changing y plus y equals 3 into s cubed plus s squared changing s plus 2s squared changing s plus 2s changing s all squared plus s changing s all squared plus changing s all cubed. We now multiply by 3. This is 3s cubed plus 9s squared changing s, that is s squared changing s plus 2s squared changing s will give us what? 3s changing s or square changing s times 3, which is 9. The same here, 2s changing s or square plus s changing s or square is 3x, then times 3. That is 9x changing s or squared plus 3 changing s or cube. Recall that y is who? 3s cube. So this equals this 9s squared changing s plus 9s changing s or squared plus 3 changing s or cube. If you like, you can just cancel out direct like this. But if you don't want to, you just say, taking this to left hand side, whereby 3s cube will now subtract itself from 3s cube. Meaning that changing y equals 9s squared changing s plus 9s changing s all squared plus 3 changing s all cube. This is going to give us, after dividing through by this, it's going to give us what you see now. That is 9s squared plus 9s changing s plus 3 changing s all squared. So the y all over the s, as the s approaches 0, the y all over the s equals 9s squared plus 9s0 plus 3 into 0 all squared. Our solution is what? 9s squared. So for this 3s cube, the solution is who? 9s squared. You keep the answer. You now come for 2s squared. 2s squared, let's solve it. For 2s squared, if y equals 2s squared, changing y plus y equals 2 into s changing s all squared to give us 2 into s changing s changing s to give us 2 into s squared plus 2s changing s plus changing s all squared. Let's multiply out the y plus y will give us 2s squared plus 4s changing s plus 2 changing s all squared. Bringing the value of y, which is 2s squared, it will give us 2s squared plus 4s changing s plus 2 changing s all squared. So this can cancel this. Changing y equals 4s changing s plus 2 changing s all squared. Let's divide through by changing s. When we do that, this will now give us that the y ds equals 4x plus 2 changing s. As changing s approaches 0, the y ds equals 4s plus 2 times 0. So the answer is what? 4x. You come to this place, you know that 2s squared when differentiated is what? 4x. Let's also differentiate when y is 5x. For 5x, changing y plus y equals 5 into s changing s to give us the y plus 5s equals 5s plus 5 change in s. Change in y equals 5s plus 5 change in s. When we transfer this minus 5x, so this will cancel this. It's something as well will cancel this way. The y all over the s equals 5 change in s all over the s. So this will cancel this. The y all over the s equals 5. Now you fix your answer. The derivative of 3s cubed plus 2s squared plus 5s will now give us what? That change in y all over change in s equals 9s squared plus 4s plus 5. And that is the final answer to that question. Under the first principle, we still have other higher ones. At that level, the one you need is this type. We have done the fractional one before. And let's first look at another aspect of the differentiation, the application area. Now, the knowledge you have in differentiation, let's see how we can apply it in some questions. Look at question 1. We need to know the curve. The gradient of a curve y equals 3s squared plus 11s plus 7. Y equals 3s squared plus 11s plus 7 at the point is minus 1. It means, first of all, get your gradient. Gradient means the y, the s. So the y all over the s for this is what? 6s plus 11. But the instruction says if this equals minus 1, so 6s will give us minus 1 minus 11. 6s equals minus 12. So we need to get the value of s. S equals minus 2. Okay? So that's the value of s. Now we have s, we don't have y. We must look for y. Then you recall that y was given as this 3s this. So when s is minus 2, y equals what? 3 into minus 2 all squared plus 11 into minus 2 plus 7. So that 3 times 4 minus 22 plus 7 will give us 12 minus 22 plus 7 to give us minus 3. Hence, the coordinate of the point P equals what? Minus 2, minus 3. This is the coordinate of the point P, minus 2, minus 3. Let's take a look at another one. Find the differential coefficient of the function y equals 1 over s squared plus 9 at the point 4, 1 all over 25. So, let us take that question and solve it. You have y equals 1 all over s squared plus 9. This thing is the same thing as saying s squared plus 9 all raised to the power minus 1. So we're going to apply chain rule. Let u equals s squared plus 9. Let y equals u minus 1. So that the u, the s equals 2x and the y, the s equals minus u minus 2 raised to the power minus 2. So when interpreted, this will imply minus 1 all over u squared. minus 1 all over u squared. So dy all over the s equals 2x times minus 1 all over u squared to give us what? Minus 2s all over u squared. Recall that u equals what? S squared plus 9, meaning that dy all over the s equals minus 2x all over s squared plus 9 all squared. But the challenge now is said the differential coefficient at the point 4,1 all over 25. 1 over 25, we are not making use of it. We are just interested at the point of x. So the y, the differential coefficient, will now give us, it will imply minus 2 into 4 all over 4 squared plus 9 all squared. Then this will give us minus 8 all over 16 plus 9 all squared to give us minus 8 all over 25 all squared. You multiply it out, 25 into this 0, 5, this is 5, carry 2, 10, 12, 5, 2, 6. So we'll have minus 8 all over 6, 2, 5. Therefore, the differential coefficient of the function y equals 1 all over s squared plus 9 equals what? Minus 8 all over 6, 2, 5. So, under this application, in the next one, we are still going to talk about the minimum and the maximum problem, the rate of change, turning point, and also the point of inflation. We'll get to our next class. For now, here comes the end of this class under the application of differentiation. Thank you for participating in today's class. You can practice more questions using the ExamGuide app. The app scores and give a detailed explanation of all the questions at the end of your practice test. You can learn a particular topic of interest with different modes like study mode, mock mode, and practice mode. It also has other features that make learning fun. It is a must for all serious students. Download from www.examguide.com if you don't have it yet. See you in the next class. Don't forget to subscribe to our channel. Hit the notification bell and share the videos to people that will benefit from it. Bye.